Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be looking at the Stack Overflow developer survey in 2020. I think it came out sometime in February, I guess, and they canvassed about 65,000 users. So we're going to take a look at that a little bit and pick a little bit at the technologies that both people think are important and then what the people that are hiring think are important right after this. So like always, I'll put this link in the show notes below, and you can go and look at this more in depth on your own. But I suppose the place that we should start first is looking at, what was the purpose of this survey and what was the information that they were hoping to get from it. So what they're looking at is that they're focusing on seeking diverse representation of the respondents while asking for information about technologies and behaviors. So they structure their questions around trying to find out what people thought was important and then what people that were hiring thought was important. So I'm looking to see, this was done obviously before the pandemic came, or human malware, as we should say. After so some of the quick findings are that Python. Now this is what people thought were most loved, and Python fell from second place to third, and Rust maintained its #1 position. And if I look, I don't know if we can look down here at this. So you'll see that Rust, the most loved, so they have these three categories: loved, dreaded, and wanted. Dreaded being that this would be the least favorable, most favorable, and then what people thought that their employers were looking for. So we have Rust in the top position at 86% of the respondents. It's pretty high. TypeScript at 67%. Python was #3. Then we have Kotlin and Go, and Julia, and Dart, and some of these other languages here, Swift and JavaScript, of course. The dreaded ones are Visual Basic. Yeah, I can believe that. Objective-C. Yeah, could believe that too. Perl, assembly language. I honestly can't believe that there's still that much assembly language around today, but I could understand. I mean, some people still think that that's the fastest way to write code. At least they have the highest execution speed, but that just isn't true. The most wanted is Python, followed by JavaScript, Go, TypeScript, and then Rust way down here, which is kind of weird. I mean, why do we have Rust at 86% when want to learn. Okay, these are the things that they want. This makes no sense. If it's the most loved, why aren't developers wanting to learn it? I mean, that's kind of strange to me, but oh well. Maybe some of you guys can explain that to me in the comments below. I'm gonna scroll back up here because we're quite deep in the presentation here. So, site reliability engineers and DevOps specialists remain among the highest paid. Yeah, I believe that. DevOps is at least somewhat important. 40% work at organizations with at least one dedicated DevOps employee. I can certainly believe that. Oh, I don't know why they would ask that question, but when they're stuck, they go to Stack Overflow. Yeah, Stack Overflow is used quite heavily by people. I've used it myself on occasion. Like all places, you have, you can get a wide variety of answers, some good ones and some not so good. But for the most part, the answer is that if I've been stuck on something, the answers I've gotten have been very good. Most developers work overtime. Yeah, they sure do. Experience by country. Oh, this is the highest amount of coding for 16.9 years in Australia. Well, by the U.S. We'll have to look at some of these more in depth. Only 0.3% never visited Stack Overflow. I guess that would make sense. 40% used, yeah. It's always good to have, multiple opinions if you're looking for something that is particularly difficult to do, that you're just stuck with, or it's not performing the right way. Find at least somewhat more welcome than they did last year. I think, it's like anything else, right? You get out what you put in. If you've done some of your homework first, and you go to these guys and you say, hey, I've done this, and I've tried this, and this is my results, and I don't think this is right, you'll get a very good response. If you go in and you're just asking questions that you should have done your homework on first, it's like anything else. You're probably going to be met with a little bit of friction. At least I've seen that a couple of times. Not too much though, but a couple of times I've seen that. So, yeah, people of color are underrepresented among professional developers. That is certainly true. Also, like I had mentioned before in a previous post, that when I started, this field was dominated by mostly women. And that is no longer true. It is just the opposite. And this survey, it definitely shows that. So I don't know what exactly has happened. The type of work involved in the early days was, there was still the hardcore engineering side of it, but the operations side, the programming side was, and the data preparation side was all dominated by women. Our operations staff was female, our programming staff was female. The data prep or the key punchers were female, and it was just occasionally one or two guys that were in working with them on various systems. But I don't know what happened. I don't know what really changed. I still don't know. It seemed like once we got out of the batch mode and into the online, the balance of the genders changed. And I don't know if that was the reason why it changed. I don't know, but I just don't know. So here we have, the question here is what? Oh, what type of developer are you? Are you a back end? It's going to be about 50-50, full stack, front end, yeah, about a third. Front end work is important, don't get me wrong. Typically, this would be the user interface people. If you look at a traditional, where you have a 3-tiered architecture, your back end is going to be hardcore, transaction processing. The full stack would be, it might include the back end, and it might include the middleware, and it also might include the UI. There are people that do all three, although in larger organizations you'll find a split between them, and people specializing in back end, middleware, and then the front end. Enterprise apps, 23%. Don't see as much focus today on enterprise applications as much as we used to. It's more ubiquitous. It's more trying to reach, to more generalized solutions that can be reused. This is kind of weird. Mobile is growing at such an accelerated rate, and yet only 19% of the developers are on the mobile platform. Wow. I think that's probably underworked. That's probably an underworked market. That's a guess. Database administrator, that's about what it has been. It's been there. And designers, yeah. Sysadmins, yeah, about 10%. You're going to find testers are actually going to be heavier than those, and they don't seem to list those. There are people that do development for testing as well. They'll write test scripts. They'll write test routines that go in and check the requirements and make sure those are met, or the objectives. QA or test is about 8%. I think that's a little low. We usually had about 2 more testers over system admin, so I would expect that to be about 20%. Maybe that's just because of the nature of the work that I did in my later part of my years being government, where, of course, testing would be more important to them. Coding as a hobby is 78%, 21% is no. Okay. Weighted by gender. 76% yes. 76% do their coding inside of work, and 23% outside. 22% for the U.S., 21% globally. Interesting. Yeah, typically people that are hobbyists are going to be in the 5 to 9 years. I would expect a slight shift in the professional developers. I did not know too many people that stayed in programming beyond about 14 years. So yeah, that's about right. They usually moved on into other parts of the engineering side of things. It gets tedious after a while. Development is stressful because there are deadlines. There's bugs you're trying to fix. There's support issues you're trying to code around. So it does have a high burnout rate. I'm assuming that's part of the reason for that. I'm guessing based on experience, but let's see. Years coding professionally, 5 years. Yeah. 5 to 9, and then you see it just trails off. Wow, I'm down here in the minority, still coding. Coding experience by developer type. Yeah, this is what happens, is that the more experience you get, the higher you go into the organization until you reach a point where you know how to code, but you don't do it anymore. At least not very much. I mean, I still wrote code every once in a while, even though I was up at this level. But it's hard not to. You just like to jump into it every once in a while. You get tired of just sitting in meetings all the time. At least I did. Writing the first line of code. Wow, that's amazing. And then 12 to 13, and then the majority is at 14 to 15, believe that. And 16 to 17, and then it trails off. So if you haven't started to code by 14 or 15 years old, you're probably not going to go into that field. It's probably the way I would read that. Education, a little under half is BS degree, and 22% advanced. Typically, you'll find more in the engineering side of companies in the advanced degrees, where you have, master's, PhD, in the engineering side. So if you're interested in engineering, don't go by this, because they look for more of this, more of the PhD folks, because they're looking for people to lead projects, engineering projects. Not to say that they're any good, but that is the choice. Undergraduate major, most of them are in computer science. Now, based on what I talked about last week, I think that's going to shift, and I think that because you're going to find it's going to be more into the user areas, it's going to be more 50-50. So I think this. I would like to come back to the survey result next year and see if this has shrunk. I expect that it will, based on if it is true, what the survey respondents had said. Professional 62, yeah, I would expect that to be higher. But this has already shrunk somewhat. when I started, this was not a very long line. There wasn't a very large number of people graduating with computer science and computer engineering degrees. Because the reason for that was they didn't even make it to business because they got snapped up by all the computer companies that were looking for people at the time. And so a lot of these guys never ended up into commercial applications development at all. So yeah, that has shifted quite a bit. Formal education, I think about half think it's fairly important. I would agree with that. Yep. I would agree with that. I mean, you don't have to have a degree to learn how to program. There are some aspects of it, though, like I said, where the degree helps advance you in your career. That's always been true in any engineering field. Gender. Minorities by country, okay. Oh, I see, okay. Yeah, this is a huge shift from when I started, a huge shift. And like I said, this is baffling to me. I just don't get it. I was heads down during this time when I didn't even notice it until one day I just looked around and went, wow. What happened to all the women that used to work in this industry? They're all gone. I don't know what it was. Maybe they got tired of looking at us and decided to get out. Disability, orientation, age, 25 to 29. Yeah, usually right about here is, here and here is when you start advancing up. So, or getting out. That happens too, getting out of the field completely. $16 years, U.S. 15. Yeah. I mean, that's about, 14 years is about the burnout area. At least it was for me. I started feeling burned out by that time. So now, programming languages. So JavaScript, this is scripting and markup. Okay, so of the scripting, and SQL is considered a scripting language? Okay. Python, yeah, Java. Java is a compiled interpreted language, but how do they, okay. Yeah, I could believe that. I mean, it's still, the web is everything, right? And so there's going to be a preponderance of this kind of thing here. And Python is still popular among the professionals. The numbers change a bit, but the order doesn't too much until you get down here, and then PHP and TypeScript seems to flip. Frameworks. Yeah, I could believe React. jQuery, interesting. ASP.NET Express, ASP.NET. I can't believe that this is still a thing. That's older than me. No, I'm just kidding. Almost. Almost. The Django. Node.js, .NET Core. So yeah, so here we're starting to get into the frameworks that start to pull into the data sciences, the data mining, and some of those things. Now, Node.js, that's more UI kind of thing. And then .NET, that's more Windows kind of things. TensorFlow is AI, of course, React Native. Unity 3D is gaming. Ansible, 7.3, interesting. And then Terraform, that's kind of down in the more ubiquitous side of things, more into the mainstream business. I think they have, somewhere down here, they have kind of an interrelationship diagram between all of them to show you where it's good to see these things, but if you don't know how they're used and where they're used in a business, you don't know where you're going to end up. And if that's not if the area of the business that you're looking to get into isn't of value to you, then you're going to bail on it in a big hurry. So databases, MySQL, Postgres, Microsoft SQL, SQLite. Wow, really? That's not a good production database, by the way. MongoDB, Redis, Mariah, Oracle. Yeah, they priced themselves out of the market is the big problem there. And DB2 has kind of a reputation of being hard to learn. And very kind of finicky to learn, but I didn't really find that to be so much of so much true. So on the platforms, now they don't say if this is development platform, but I'm going to assume that it is. So Linux has the highest number of interest over Windows. It shifts a little bit downward for Windows with Docker picking up the others, of course, yeah. I can understand that growth. And then, Docker AWS. And then, this is big. This is surprising. And then Raspberry Pi. I wonder how that, can't imagine Raspberry Pi being on that list very high. No, it's not. That kind of falls down a bit. That's kind of a makers, Arduino kind of thing. If you're interested in hardware engineering, that's a good platform to play around with, or robotics or whatever. And then we looked at this one earlier. Rust, Python. Most loved is ASP.NET. Okay. Drupal. I know a lot of people use Drupal. And the most wanted is React, Django. Interesting, because this one did not, this is by people that want to learn, but yet Django was not up on the list of things that were most likely to be found. And that's kind of the way I kind of looked at that. And then Flutter, Pandas, Terraform, Keras, TensorFlow. These are all, we'll get down here on the bottom and we'll look at some of that. Databases. I'm not going to go through all of this. Wanted platforms. Most loved is Linux. 76%. Wow. Docker 73%. WordPress. Yeah. IBM Cloud or Watson. This has kind of connotations of being very complicated. Heroku. And wanted to learn, Docker, AWS, Kubernetes, and Linux. I have certainly found this to be true on my channel. These have a higher, I've done Docker and I've done a little bit on Kubernetes. Those have a higher interest rate overall over Linux, but yet this is still pretty high from my experience with the channel. Primary interest, this is kind of surprising here. I didn't expect to see Linux quite this high because typically this is workstations. Unix and Linux traditionally have always been kind of popular. That's why the Mac had such a favorable growth rate back in the 90s and the early part of 2000. Is simply because the people that were developing found that platform a lot easier to develop on, particularly if you were doing C or C++ or Objective-C kind of work. It was just a lot better. Collaboration tools, GitHub, research tools, start a free trial. Okay. Probably the thing that you'll be the most interested in. Now, that's global. Let's look at it for here. Scala, Data mining, definitely. Go, Ooh, surprising that this would be that high. I don't think that would be worth I wouldn't be worth my time to be paid that for Objective-C, I'll tell you that. I'd want a lot more. Haskell. Haskell is a language that maps one-to-one mathematics with the programming language, and you find it a lot being used in high-performance computing environments, particularly where you're offloading code to a graphics processing unit. Haskell is very good at that, and it strictly it sets aside kind of the traditional programming language model, and it's more. If you have a formula for how to do something, a math formula, it maps pretty easily into Haskell. I've only used it a bit, and that's kind of my impression. I could be wrong, but that's kind of the impression I walked away with when I played around with it a bit. Here we go. So, you'll see Scala, Hadoop, Apache Spark up here in the big data. And then this is AI, and it's kind of tied into the data gathering parts of it. Yeah, Ansible to manage the infrastructure, Kubernetes to manage the scaling of the system as the load increases. Raspberry Pi kind of off here by itself. 3D programming, gaming, or simulations. I have seen instances of this, believe it or not, being tried in kind of an experimental vein as a UI. Particularly if you have young kids that are coming in that you need for operations or operators, giving them a controller, an Xbox controller to manage the system with. Takes a lot less energy and a lot less time to train them than it would be to have them learn a mouse and a keyboard. I'm serious. I mean, that's true. C++, C, assembly over here in the kind of the traditional OS kind of things. And then this looks like Android down here and all this. And then here's your traditional kind of enterprise back-end kind of thing. So, yeah. Learning a new tech every few months, 37% once a year. I mean, it depends on, the right answer here, it depends on what industry you're in, right? I mean, some industries like financial industries, if you're in like Wall Street, those change like daily almost. If you're in banking, those don't change unless there's bank regs that change. So those stay pretty constant. If you're in engineering and you're doing high-tech development or you're in high-tech sales, you'll probably find more of this and less of that. It'll be more every few months. There'll be major changes that you have to learn every year, but new things will be coming on every month. Yeah, where do you get stuck? And unemployment status. So, I don't think I'm going to go too much further down. This kind of explores a little bit about company size and onboarding and career value, looking for a job. So, here's some sage advice. The avocation is the most important part of any job. Money is always a good reason to do something, but don't choose the money as the sole reason to choose a job. If you're not happy, they couldn't pay you enough. So, so just realize that it's more important that you're happy in the job that you do, and make sure that is your avocation. That's something that you really enjoy doing. And if it just happens to pay you the right amount, great. If you get a little less, hey, sometimes that's all right, right? I mean, happiness is kind of priceless, and you can't really put a price tag on it. So that's some sage advice for you. I don't have too much more on this. Kind of my overall impressions. I was kind of surprised by a few things. I was kind of surprised by Rust being the most loved and yet the most uncommon to be asked for to be wanted to learn. That just seems odd to me. Rust is a very good language, don't get me wrong, and so is Go, and so is Python. Python has, all language have this kind of a life cycle they go through, and that when they're at their base level, they're very quick, very efficient, and they're easy to learn. But over time, all these additions and add-ons and things that get bolted onto the language to do different features and functions, that makes it more complicated. It also means that you have to know what things to add on in order for a particular piece of code that you want to run. Maybe you didn't write it. Maybe it's something that you got off of GitHub or GitLab. And you need to understand what to install in order for it to work, and more importantly, what versions that particular piece of software needs in order to run as well. So, and you'll find that kind of happening. I mean, I saw a Java way back on, I think it was 0.96. It wasn't very fast, but it was very efficient to write things. So they didn't have a hot compiler yet or a hot interpreter. So, but over time, they just kept adding on more and more and more core functions until it just got so complex that I lost interest in it, to tell you the truth. It just got to the point with it where you were always looking for the library and the bundle that you needed in order to get it to function. And after a while, it just became a game of, well, let's see how far the program will run before it tries to find a library it doesn't have. Anyway, I hope you enjoyed this little short topic today. I kind of stretched it out a little bit, and I probably shouldn't have. But, yeah, it's always good to take a look back. It'll be interesting to come back to that next year and see. I'm kind of interested to see if that shifted any on the computer science side of things, being the highest number of people that are coming into the field, since the CIO survey says they're looking for people that know the business more. So it'll be interesting to see if that shifts. Hope you enjoyed this today. Hope to see you all again real soon. Take care and bye for now.